In this video, we are introducing level curves. A level curve provides us with a method for representing a three-dimensional surface using two-dimensional curves. And these are also sometimes called contour lines. Each curve, each of the level curves, is going to represent a constant elevation. And let's take a quick look at an example. First, let's generate a three-dimensional drawing of this surface, and then we'll draw the level curves in two-dimensional space. So we'll start by identifying what the trace curve looks like in some specific z elevations. So we'll look first at z is equal to 0, which is basically the floor, and then we'll look at the plane z is equal to 1 and see what the trace curve is in that plane. We'll also look at the trace curve in the plane z is equal to 4, and this is going to help us to generate this three-dimensional drawing. So let's start with the xy plane, the floor, the plane z is equal to 0. When we plug 0 in for z into the equation, we get x squared plus y squared. And there's only one solution to this. The only solution that we have is when both x and y are equal to 0, because two real numbers squared are always going to be positive. And when I add those two things together to get 0, they must both have initially been 0. So we only get a single ordered triple in the z is equal to 0 plane, or in the xy plane that is the floor. In the plane z is equal to 1, we plug 1 in for z and we get x squared plus y squared, which is a unit circle. So in the plane z is equal to 1, we're going to come out 1 unit in the direction of x, 1 unit in the direction of y, and then graph a unit circle as the trace curve in that plane. And let's just label that as being the z is equal to 1 plane. Now let's do this again for z is equal to 4 plane. We'll plug in 4 for z, and we see that in this plane we also get a circle centered at the origin, but this time the radius is 2. So up here at 1, 2, 3, 4, the z is equal to 4 plane, we're going to draw a circle radius 2. So we're going to come 2 units out in the direction of x both ways, 2 units out in the direction of y both ways, and then draw a circle in this plane whose radius is 2. And this is the z is equal to 4 plane. Now we can already see what's happening here. This is a circular paraboloid. We're going to get parabolas if we were to slice it with a plane parallel to either the xz plane or the yz plane, and we get circles when we slice with constant z planes or planes parallel to the xy plane. Let's grab one more trace curve at z is equal to 7. So we're looking at the same change in elevation from z is equal to 1 to z is equal to 4, then from z is equal to 4 to z is equal to 7. So we went up 3 units from these two trace curves and 3 units between these two trace curves. In the z is equal to 7 plane, we get 7 is equal to x squared plus y squared, again a circle, but this time the radius is the square root of 7, which is approximately 2.65. So let's travel up to the plane z is equal to 7, which will be somewhere up here, and now we have a circle centered at the origin, and we're going to go 2.5-ish, 2 and a little bit more than a half in the direction of x and in the direction of y to get a circle in this plane. So now that we have this trace curve, I'm going to try again to get our circular paraboloid to get closer to the edges of those circles. And what I'm hoping to illustrate here is that we're actually getting steeper and steeper as these z values are increasing. So let's envision a light that is up here shining down on this curve and projecting these trace curves, casting the shadow of the trace curves onto the xy plane. So let's take a look at R2, which basically is the xy plane. And essentially we're going to graph those shadows. So that ordered triple in the xy plane, that basically just gives us this one point as its shadow. Let's say that's what happens in the z is equal to 0 plane. When we were at z is equal to 1, we ended up with the unit circle. So we'll label each one of these level curves with the elevation that it represents. In the z is equal to 4 plane, we ended up with a circle centered at the origin with radius 2. So we'll label this level curve with the elevation that it represents. Now our next level curve happened in the plane z is equal to 7. That ended up being 2.65, a little bit more than 2.5. And what we'll notice here is that these level curves are getting closer and closer together. We had the same elevation change, 3 units to get from 1 to 4, and 3 units to get from 4 to 7, but these two level curves are farther apart than these two level curves are. And the closer the level curves get to each other, the steeper the graph is at that point. So this is how we can represent a three-dimensional surface using level curves.